Welcome to Ask and Learn.
The first step will be to find the spring constant K. And so K is force over extension. And so that's 760 newtons over 5 times 10 to the negative 4 meters. So that's 0.5 millimeters, 5 times 10 to the negative 4. This gives us 1.52 times 10 to the 6 newtons per meter for a spring constant. Second step is to equate energies. So energy before equals energy after. Before, you just have potential gravitational potential energy, mg times y1, the height, and that's equal to potential energy afterwards, mg y2, plus the elastic potential energy from the spring, 1/2 k times y2 squared. Okay, so we want y2, everything else we have here. So y2, so multiplying both sides by 2 over k, or by 2 over k gives us y2 squared plus 2mg over k times y2 minus 2mg over k times y1 is equal to 0. Okay, and so mg, remember the scale reads 760 newtons, so F equals mg is 760 newtons, and mg over k is 760 over 1.52 times 10 to the 6 newtons per meter, and that is basically 5 times 10 to the negative 4 meters, or 0.5 millimeters, which we I guess already knew. But so yeah, so that's mg over k, and y1, as we know, is 1 meter. So we can put that all together here, y2 squared plus 2 times 5 times 10 to the negative 4. So that's 1 times 10 to the negative 3. y2, not plus, that's a minus there. Minus, again, 2 times 5 times 10 to the negative 4, y2 is equal to 0. And so you get y2 squared plus 0.001, or 1 times 10 to the negative 3 y2 minus 0.001 is equal to 0. And so we can use the quadratic formula to solve this equation, and we get two answers for y2. One of them is negative 3.21 times 10 to the negative 2 meters. The other is 3.11 times 10 to the negative 2 meters. Now, we may be tempted to just take the positive answer, but that would not work in this case. Remember, we want the scale reading at its peak. And so the peak height will be whatever has the larger magnitude of y. So 3.21, negative 3.21 times 10 to the negative 2 meters is the larger absolute value of these two. So that's the one we take. And so for peak reading of the scale, we have F equals kx, or ky, but the magnitude of y. So that would be k times this value. So k is 1.52 times 10 to the negative 10 to the 6 newtons per meter times 3.21, just the magnitude of it, times 10 to the negative 2 meters. And this gives us about 4.9 times 10 to the 4 newtons, or 49,000 newtons. And that's it.